In 1989, anti-lock brakes became available as an option on some Jeep XJ models. The purpose of anti-lock brakes is to prevent wheel lockup under heavy braking conditions. A vehicle with anti-lock brakes will prevent the wheels from locking, allowing the vehicle to retain directional stability and steering capability. Hello, and welcome to the August 1990 edition of VideoTec. The anti-lock brake system represents the current state-of-the-art technology in vehicle brake systems and offers the driver increased safety and control during braking. The system is being offered as an option on the 1989 and 1990 Jeep Cherokee with SelectTrack four-wheel drive and the 1989 and 1990 Wagoneer, also equipped with SelectTrack four-wheel drive. In this program, we're going to be talking about the Bendix anti-lock brake system used on the Jeep XJ. We'll be discussing system components, performance characteristics, service, and diagnosis. But first, let's talk about how an anti-lock brake system works. Wheel speed sensors are located at each wheel. The sensors send signals to the anti-lock electronic control unit, or ECU. If a wheel locking tendency is detected, the ECU signals the pressure modulator to modulate brake fluid pressure. The pressure at the wheel is then modulated until the locking tendency is over. The anti-lock brake system is a three-channel design. Brake pressure to the front wheels is controlled by two individual hydraulic channels. The third hydraulic channel controls pressure to both rear wheels. The ECU constantly monitors wheel speed in order to control the anti-lock braking process. The anti-lock function will shut down when the vehicle slows to below 3 to 5 miles per hour. The brain of the anti-lock brake system is the electronic control unit, or ECU. The ECU monitors the brake system at all times and controls it while it functions in anti-lock mode. When a wheel locking tendency is detected, the ECU signals the appropriate wheel circuit valves in the pressure modulator to modulate brake fluid pressure to prevent wheel lockup. The ECU also monitors the system for proper operation. If the ECU senses a system fault, an instrument panel warning light is illuminated, and the fault is stored in the ECU memory. Finally, the ECU communicates with the DRB2, allowing fault messages to be accessed, system states to be determined, and tests to be performed on the system components. The ECU is located under the rear seat and connects to the wiring harness through a 24-pin and a 32-pin connector. A mercury switch is mounted inside the ECU, which is positioned at an angle. From this position, the mercury switch senses vehicle deceleration and provides input to the ECU for improved system operation on slippery surfaces. Since the ECU's angled position is important to system operation, it must be mounted correctly. The power-up voltage source for the ECU is through the ignition switch in the on or run position. Battery voltage is also provided for the ECU memory. The ECU receives signals from wheel speed sensors at each wheel. Based on these inputs, the ECU can detect wheel locking tendencies. These signals are produced by magnetic induction when a toothed sensor ring or tone wheel passes a magnetic wheel speed sensor. The front tone wheels have 117 teeth, and the rear tone wheels have only 51 teeth. There must be a space between the tone wheel and the sensor when installed properly. This is called the air gap. It is adjustable and critical for correct operation of the anti-lock system. The hydraulic assembly is located on the driver's side of the engine compartment. It includes an actuator, pressure modulator, diaphragm-type accumulator, proportioning valve, and various switches. The actuator portion of the hydraulic assembly functions as a master cylinder and power booster. Like a conventional system, the master cylinder is split front to rear. A ball valve is contained in one end of the primary piston. The ball valve is activated by the pedal rod and provides boost pressure to the master cylinder and pressurized fluid to the modulator. The system uses a conventional proportioning valve and differential pressure switch located next to the actuator. It monitors pressure differences between the front and rear brakes. If an incorrect pressure differential exists, a signal is sent to the ECU, a fault is set, and a warning light is illuminated. The differential pressure switch and proportioning valve operate normally in standard braking mode. During anti-lock braking, the proportioning valve is bypassed. The pressure modulator is the heart of the anti-lock system. During anti-lock operation, the pressure modulator provides 3-channel pressure control. One channel controls hydraulic pressure to the rear brakes. The 2 remaining channels control hydraulic pressure to the front brakes individually. The modulator contains 9 solenoid valves, with 3 valves assigned to control each channel. Each channel contains an isolation valve, decay valve, and build valve. During standard brake operation, master cylinder pressure passes through the isolation solenoid valves to the wheel brakes. But during the anti-lock mode, the isolation solenoid valves block fluid pressure from the master cylinder ports. This allows brake pressure to be modulated through the build and decay solenoid valves, while isolating the pressure modulations from the brake pedal. The boost pressure differential switch is mounted in the pressure modulator. Its job is to detect a loss of boost pressure. If a boost pressure fault exists, a warning light will illuminate and a fault will be set. The fluid reservoir holds the brake fluid before it's pressurized. The correct fill level is marked on the reservoir. A filter located under the reservoir filler cap is designed to keep contaminants from entering the reservoir. A diaphragm-type accumulator is also located on the hydraulic assembly. It stores pressurized brake fluid used for hydraulic assist. The low-pressure accumulator switch is located next to this accumulator. It monitors the pressure in the accumulator. If pressure drops below 1,050 psi, a fault is set and a warning light is illuminated. The booster pump and motor supplies pressurized fluid to the accumulator for normal and anti-lock braking. The booster pump and motor assembly is located in the engine compartment on the passenger side. The booster pump takes low-pressure fluid from the fluid reservoir and pressurizes it. Booster pump operating pressure ranges between 1,650 and 2,050 psi. When the boost pressure drops below 1,650 psi, the booster pump pressure switch activates the booster pump relay, which supplies battery voltage to turn on the booster pump motor. After the pump has raised the fluid pressure to about 2,050 psi, the pressure switch turns the pump off. This normally takes 8 to 10 seconds and will occur every 4 to 6 brake applications. In addition to the diaphragm-type accumulator on the hydraulic assembly, there is a piston-type accumulator in the booster pump and motor assembly. Under normal operation, fluid is stored in the accumulators at high pressure. It's extremely important that system pressure be relieved from the accumulators when servicing the anti-lock brake system. This is done by pumping the brake pedal a minimum of 50 times with the ignition off or the battery disconnected until a hard brake pedal is felt. Additional switches related to the anti-lock system include the stoplight switch, parking brake switch, and ignition switch. The stoplight switch is found on the brake pedal linkage. When the brakes are applied, it sends battery voltage to the ECU. The parking brake switch is located in the parking brake linkage. It's part of the ECU's low fluid switch circuit. Finally, the ignition switch supplies battery voltage to the ECU and pump motor when in the on or run position. Two indicator lights are used with the anti-lock brake system: a red brake warning light and a yellow check anti-lock light. They're located on the left side of the instrument panel. The red brake warning light indicates a brake system condition that may result in reduced braking ability. Conditions which may cause the red brake warning light to illuminate include low brake fluid, low accumulator pressure, a master cylinder malfunction, or a parking brake that has applied or not fully released while the vehicle is moving. The yellow check anti-lock light indicates a condition which resulted in a shutdown of the anti-lock brake system. Most conditions which turn on the red brake warning light will also turn on the yellow check anti-lock light. When the check anti-lock light is illuminated, the anti-lock function is not available. Both lights illuminate at startup and go out when the self-diagnostic program determines that system operation is normal. If the ECU detects a fault, the check anti-lock light will illuminate until the fault condition clears or the ignition switch is cycled, but the fault message will be stored in the ECU memory. The yellow check anti-lock light may also illuminate in tandem with the red brake warning light to indicate some types of faults. There are 3 relays used in the anti-lock system. They are the modulator power relay, the yellow light relay, and the booster pump motor relay. The modulator power relay and the yellow light relay are located in the engine compartment on the driver's side inner fender panel. When the system is powered up, the ECU supplies battery voltage to the modulator solenoids through the modulator power relay. When the modulator power relay closes, battery power is sent to the yellow light relay, which closes and turns the check anti-lock light off during normal operation. In the case of a system fault, the modulator power relay opens, opening the yellow light relay, turning on the check anti-lock light. The booster pump relay is located under the booster pump bracket on the passenger side of the vehicle. It's not controlled by the ECU. It is controlled by a pressure switch located on the pump assembly. When energized by the pressure switch, the relay closes, energizing the booster pump motor. The booster pump relay has wider terminals than the other 2 anti-lock relays and is not interchangeable. The main fluid supply is stored in the fluid reservoir. Fluid is supplied to the booster pump from the reservoir through a low-pressure hose, the larger of the 2 hoses. A high-pressure hose runs from the booster pump and its accumulator to the accumulator on the hydraulic assembly. Up to this point, we've covered the individual components of the anti-lock brake system. Now, let's get into the system's performance characteristics. When the ignition switch is turned to on, power-up voltage is provided to the ECU, and the ECU exercises the modulator solenoid valves as part of the system's self-check. At this time, the instrument panel lights illuminate for a brief period of time and then go off. After engine start, the booster pump may come on for a few seconds to build brake system pressure. The pump will cycle periodically to maintain system pressure. During power-up, you may hear clicking noises as the solenoids in the modulator are activated. You may also hear the booster pump and motor running. If the brakes are applied during power-up, you may feel a slight pulsation in the pedal. Under normal conditions, pedal feel is similar for vehicles with and without anti-lock brakes when the vehicle is moving. When the vehicle isn't moving, pedal feel may be a little different than with a regular vacuum assist brake system. Pedal feel should not be used as a means of evaluating the anti-lock system. During brake pressure modulation, as brake pressure is increased, some wheel slip occurs. This slip will result in some tire chirping, depending on road surface. Understanding the system and how it performs will aid you in diagnosing system problems. Let's talk about anti-lock brake system diagnosis. Anti-lock brake system diagnosis involves 3 basic steps. First, check the indicator light display sequence. The 2 indicator lights will illuminate separately, at the same time, or with different delays depending on the fault. The lights signal low fluid levels, pressure drops, and other hydraulic and electrical faults. A diagnosis chart is available in the service manual to help you use the indicator light display as a diagnostic tool. You should also make a visual inspection of system components. Check the reservoir fluid level. Check for leaks throughout the entire system and look for loose connections or damage. Finally, use the DRB2 and the 1990 Powertrain Diagnostic Procedures Manual for Jeep XJ anti-lock brakes to help with your diagnosis. The DRB2 provides 20 fault messages for diagnosing the anti-lock system. The DRB2 also provides a number of system tests and state displays to determine if the anti-lock system is working properly. A fault message indicates that an anti-lock system fault has occurred. The anti-lock brake system test is a functional test of the ignition switch, brake switch, parking brake switch, and the yellow check anti-lock and red brake bulbs. State displays show the condition of various components and functions while the system is operating and can be used to check for intermittent faults. When using the DRB2, be sure the battery is fully charged. Then, connect the DRB2 with the 1987 through 1990 Jeep Eagle cartridge and the Jeep Eagle adapter to the diagnostic connector. The DRB2 screen will display the introduction screen, then the first DRB2 menu. The DRB2 will display 4 choices. To get to ABS Diagnostics, select choice number 4, Select Vehicle. You are then asked to select the vehicle, model year, trans type, with or without air conditioning, and with or without ABS, and confirm your choices. To confirm your choices, go to the line that reads Confirm and press Enter. The DRB2 will then display a main menu. Select either System Tests, Read Faults, or State Displays for the anti-lock brake system. If you make a wrong choice, pressing ATM will return you to the previous menu. When diagnosing the anti-lock system, the first step is to check for fault messages. With the key on, select Read Faults by pressing 2 on the DRB2 keypad. Then press 1 for ABS. If a fault has been stored, a fault message will be displayed. Up to 3 fault messages can be displayed at a time, and the fault messages are saved when the ignition is turned off. When fault messages are displayed, you should make note of them and then clear them from the system memory. Faults read at the initial reading should only be used as a guide, because some driving or operational situations can cause faults in an anti-lock system that is actually operating correctly. These are called driver-induced faults. Driver-induced faults can be set by driving with the parking brake applied. Driver-induced faults can also be caused by excessive wheel spin on low traction surfaces. To clear the system of faults, disconnect the battery or remove the ABS battery fuse in the fuse panel for about 10 seconds. After you have cleared the system of fault messages, restart the vehicle and check for a brake or check anti-lock warning light. If either warning light remains illuminated, check for fault messages. If the lights do not remain illuminated, the vehicle should be road tested. After road testing the vehicle, check the system for fault messages. Also, perform the system test to completely test the system. During the system test, you are asked to turn the key off, then turn the key on. Set the parking brake and release the parking brake. Press the brake pedal and release the brake pedal. Crank the engine and observe the instrument panel lights, and turn the key off and turn the key on again. At the end of the system test, the DRB2 will display any stored fault messages. If a fault message is displayed, use the 1990 Jeep XJ Anti-Lock Brake Powertrain Diagnostic Procedures Manual along with the DRB2 to diagnose the fault on both 1989 and 1990 vehicles and make the necessary repairs. For example, after road testing the vehicle, you discover a right front wheel speed sensor fault. The diagnostic test for a right front wheel speed sensor fault is number 817. The first question asked is, did the fault occur on ice or gravel? Since the vehicle was just road tested, the answer is no. Next, check the right front wheel speed sensor for the proper air gap. If the gap is correct, you'll have to check the electrical circuit to the sensor. First, check the resistance of the speed sensor and harness. To do this, disconnect the sensor connector located at the ABS harness in the engine compartment and measure resistance across the component side of the connector. If resistance is between 5,000 and 8,000 ohms, the sensor and its harness are okay. If not, the sensor or harness is faulty and should be replaced. If the sensor is okay, the next step is to check the harness between the sensor connector and the ECU. To do this, remove the screws attaching the ECU mounting bracket to the floor pan riser and the screw attaching the mounting bracket tab to the floor pan. You can then disconnect the 32-pin connector at the ECU. Now, measure resistance across the harness side of the sensor connector. If resistance is below 5 ohms, the sensor wires are shorted together. If the sensor wires are not shorted together, the next step is to check for an open circuit in the harness. First, check the violet wire. Measure resistance between cavity C14 of the 32-pin ECU connector and the harness side of the sensor connector at the violet wire. If resistance is above 5 ohms, the circuit is open. If the circuit is not open, measure resistance to ground at ECU connector cavity C14. If resistance is below 5 ohms, the violet wire is shorted to ground. If the violet wire is okay, check the orange wire at ECU connector cavity D14 for an open circuit or short to ground. If the circuit to the sensor is okay, the ECU is faulty. That's one of the diagnostic procedures used to diagnose a fault message. The other procedures used in the Diagnostic Procedures Manual are just as easy to follow. The components and switches in the hydraulic assembly are not repairable individually. If diagnosis indicates that a malfunction has occurred in any of these components or switches, the entire hydraulic assembly must be replaced. The electrical harnesses, pump bracket, pump high pressure and supply hose, system relays, pump and motor assembly, and wheel sensors can be serviced individually. The tone wheels are permanently attached to the axle shafts and can only be replaced as an assembly. Oh, and one more thing. The hydraulic assemblies used in 1989 and 1990 vehicles are not interchangeable. Proper fluid level is important to system operation. The brake fluid recommended for use with the anti-lock system is MOPAR brake fluid or equivalent meeting SAE J1703 and DOT3 standards. To check the fluid level, first fill the reservoir to the full level. The fluid level indicator is on the driver's side of the reservoir. The reservoir should be filled to the top of the V-shaped max indicator. Now, start the engine and pump the brake pedal until the pump and motor energizes. This will fill the accumulators with fluid. When the pump motor energizes, stop pumping the brake pedal and wait till the pump shuts off. Then, turn off the engine. The system accumulators are now full, and the fluid level should be checked and fluid added if necessary. Since the anti-lock system is dependent on signals from the wheel speed sensors, it's important that they operate properly. There is one wheel speed sensor at each wheel, and the sensors are wired to the ECU. The rear sensor connectors are located next to the ECU. The front sensor connectors are in the engine compartment. The left front sensor connector is located between the driver's side inner fender panel and the hydraulic assembly. The right front sensor connector is located at the anti-lock harness near the booster pump and motor assembly. To remove a wheel speed sensor, first, disconnect the wheel speed sensor connector. Then, remove the grommet in the wheel housing or floor pan and pull the connector through. To remove a front sensor, loosen the sensor retaining bolt and remove the sensor. To remove a rear sensor, remove the wheel and brake drum and unseat the sensor support plate grommet. Remove the bolt attaching the sensor to the bracket and remove the sensor by pulling the wire through the grommet hole in the support plate. When installing a replacement wheel speed sensor, there is a plastic spacer attached to the sensor contact face, which sets the air gap. Be sure the spacer actually touches the tone wheel. Then, tighten the adjusting bolt to 11 foot-pounds. When installing or checking the gap on the original sensor, remove the remains of the old spacer and clean the sensor face with MOPAR brake parts cleaner. Install the sensor and use a brass feeler gauge to set the gap. The air gap for the front and rear sensors are different. The front sensor air gap is 13 thousandths to 19 thousandths. The rear sensor air gap is 30 thousandths to 36 thousandths. Note that there is a correction to the 1990 Jeep XJ Anti-Lock Brake Diagnostic Procedures Manual for the left and right rear sensor air gap. The rear sensor gap should read 30 thousandths to 36 thousandths instead of 13 thousandths to 19 thousandths. Tighten the adjusting bolt to 11 foot-pounds and recheck the spacing. Well, we've provided you with a lot of information on the Jeep XJ anti-lock brake system. We've covered operation and components. We've looked at diagnostic and performed some service procedures. This information should help you to service and repair this anti-lock brake system and provide you with a basic understanding of anti-lock brakes that will help you to understand future anti-lock brake systems.